Hello everybody. In this video, we will go over object detection and spatial reasoning with Qwen 2.5 VL. Let's get started. We will first install Qwen VL utils, and this is a utility for Qwen VL model. Next, we have our standard imports. We have seen these imports so many times, it doesn't make sense to go over them again. But we have some new imports. We are going to use regular expression, RE, for some text cleanup. We will also use JSON. This is a standard object format. And this utility, this package is used for parsing JSON files or JSON format and also serializing them. And then pprint is used for printing JSON in a pretty way. Nothing out of the ordinary here. From PIL, usually we use only the image package, but here we also we'll need to draw the image. We'll need to draw bounding boxes as well as put text on the bounding box for the class names for object detection. And that is why we have image draw and then fonts and color. Other than that, we will import process vision info from Qwen VL util. We had done this before in the previous notebook on image captioning as well. So it's also standard. So before we start, before we go into the vision part, before we go into the main thing, we have to write some utilities for parsing JSON files or parsing JSON objects. And you will see later in this notebook that when we ask for an output, when we ask the model for an output, it returns the output in this format. Even when we say that we want the output in JSON format, it basically returns it in this format. It says that this is the JSON piece. So, but the actual JSON object is right here, right? So we need to write some utility to remove these parts, right? And that is what this piece of code is doing. Doesn't make sense for me to go over this. You can go over this code. It is well documented. You can see what is going on. And all it's doing is removing this part. And that piece is done in right here, extract JSON. And then sometimes what happens in the output, the text that is returned, for example, the class name, it can have a new line character, which is not standard JSON format, but this model sometimes outputs this new line character within a string. And so we are basically going to repair that new line character, and it happens right here. So sometimes we will first try to load the JSON. If it gives an error, then we will basically try to repair it, and usually that fixes the problem. In any model, when we want to get structured data, sometimes they have little mistakes which we need to fix. And you do not see these mistakes in commercial models like OpenAI, because they do all this testing for you already before they send you the output. But here, sometimes using prompt alone, it's very difficult to fix the problem. So we fix it in post. All right. We also need some utilities for displaying image. So this is basically, it takes in a pillow image and displays it. We also have some code for displaying bounding boxes. So it will take this JSON object in this format. So the bounding box coordinates X, Y, width and height, they are under this bbox 2D. And we also have a label, and the label gets displayed on top of the bounding box. So, and you could have an array of these objects, right? You can see that there's an array of these objects. And this is, basically drawing utility, right? And we are not going to go over how this drawing utility works, because it's very well commented, and also because this is not the core of what I want to teach today. Okay, but it is, you can use this utility as is, very well commented code, so you can use it. Now let's go to the main piece. Okay, first we are setting up the device. We are setting it to be CUDA, which means that we have an NVIDIA GPU. And if CUDA is available, we are going to use CUDA, the NVIDIA GPU. And here you can see that I have already set my runtime to A100 GPU, which is a CUDA GPU. And so we'll be able to use it. Next, we have to define the model ID. Here we are saying that the model is Qwen 2.5 VL7B. This is a 7 billion parameter model. In the previous notebook, we had used a 3 billion parameter model. And if your GPU, if you do not have a paid version of Google Colab, and if you are running into problems, then you can convert this. You can simply change this text to 3 billion right here, change it to 3, and that piece will work also. Now we basically want to load this model. For loading this model, we use Qwen 2.5 VL for conditional generation. This is where the model is loaded from. You can see from pre-trained, we give it the model ID, and we also tell it to automatically select the right data type. For example, if it is running on a GPU, then the data type would be FP16. And if we are running it on the CPU, then it would be FP32, right? 32 bits floating point versus 16-bit floating point. Also, the device, we have the device map, we have set it to auto. And this makes sure that the model, it can use both the CPU and the GPU. If the model doesn't fit in the GPU, then it can use the CPU. And a device map _ auto should take care of that. If it doesn't, then try using, you can change this to CPU, and then it will definitely work. But this should work. Okay. Next, we basically get the processor. As you had seen in the previous notebooks, we have to pre-process the text as well as the images that we use. So we get the processor for that. And, Hugging Face has this beautiful utility called Auto Processor. And we can basically get, for the pre-trained model, this is the model, we can get the right processor. Okay. And now we basically load the model on the device. And if you have a GPU, then it would say that the device is CUDA 0. And when we run this piece of code, all the data is downloaded. The models, it is downloaded in 5 files. There are 5 files that constitute the model. Basically, the model is so large. This is about, 3 times, this is almost 4. So this is about 14 gigabytes, 14 gigabytes of data. And they have split it into 5 parts so that it is easy to download. And there are other benefits also later on. But for mostly, think about it that you need to download it, and you can download it in parallel if you use 5 different processes. So that's what is happening here. It gets downloaded. And once the model is downloaded, you can see that it is uploaded on the GPU, which says CUDA 0. If you had multiple GPUs, you could be CUDA 0, 1, 2, 3, right? So this is where, you can see that the model was uploaded. Okay. So, okay, now we are ready to download an image. We have a URL. We get the URL. We use requests to get the URL, all the bytes in this image. And then we use io.byte.io to convert those bytes as if it's on a file system so that we can load it into our image. Yeah. So right here, we are opening the image and we are making sure that it is in RGB format. Finally, we had written a utility for displaying the image, and you can see that we have downloaded this, this image. So this is an image of an elephant. Elephants are very interesting, animals. I love this quote from Nassim Taleb, which says that the elephant, my favorite animal, takes no crap, gives no crap, harms no one, But when one tries to harm it, it has no clemency and never forgets. Little thing about elephant. I love it. I love the elephants. All right. So now we are ready to do inference on this. Basically, we want to detect objects in this picture, and we will see how you can do it using Qwen 2.5 VL. So this inference code, you remember from our previous notebook that we need to apply the chat template. Models like Qwen 2.5 VL, they have a chat template, and it's usually not in the format that we want to input, right? So we want to input our messages. So we pass in messages to interact with the model. And we want to pass in the messages in simple formats like this JSON format, right? We want to give it the role and different kinds of roles and pass in different kinds of content, as you had seen in the previous notebook. Now, obviously, this format is not supported by the model. So we want to convert this we want to process this text so that it gets in the right format. So text prompt, and all the details are in the previous notebook. So we can, if you don't understand this, you can go and revise the notebook on image captioning and you'll find it there. So, okay, so we get the text prompt and you can see that we are passing in the all the messages, and we are saying that don't tokenize the output because we are going to use the processor one more time where we are going to tokenize it. So we don't tokenize it in this part. And then we also say that, okay, add generation prompt, which is, it adds a few things it needs for prompting in the next step. So the second thing we do is we take this message. Now you have this message. It has the text part, right? You are an object detector. It also has, in this part, it also has some images, and we want to extract those images and convert them into the right format for Qwen 2.5 VL, and that is what we are doing right here. So if we had videos, we will also get the videos here. So this is pretty much general purpose inference code for Qwen 2.5 VL. So once you have the text input and the image input, we can simply pass it in to this processor, which will basically, it will pre-process the text. And here we are saying that there is only one text, which is the message that we are sending. And we have these image inputs we are passing, the video inputs we are passing, and we are asking it to return the output as a PyTorch tensor. All right. And all these inputs, then we are loading it onto the device. So perfect. Now the inputs are on the device. The model is on the device. So we can basically get the output. So we are first setting it torch.nograd. We are making sure that the autograd, which automatically computes the gradient, is not enabled, because during inference we don't need it. We need it during training. And then we, with that set, we are generating we are running inference. So we are passing in the inputs and we are saying that the maximum number of new tokens is we want is 1000. Make sure that this number is not very small. If you have a lot of objects, it is possible that these tokens may not be enough. So you have to increase it because otherwise it will cut off the text that it returns and you will not get the full text out. So, okay, now we get the generated IDs. These are tokens. These are not text strings. And we have already covered what tokens are in previous notebooks and slides. So these are basically numerical representations of words. So tokens are not exactly words, but you can think about them as numerical representations of words. And this is, I'm loosely using the word words. So you get a series of numbers here, and we want to decode the numbers, right? It's an array of numbers we get. We want to decode that array of tokens and get text out of it. And this is what this batch decode is doing here. Now, you can also see that we are decoding, but we are also removing the input that we had passed in. The thing is, when we calculated that input, the output that the model returns also contains the input, right? So we want to remove the output. We want to remove the input from the output, and that is what this code is. And we have gone over these in the previous notebooks in greater detail, and that is why I'm not explaining everything here. And we also want to skip special tokens here that it generates. Okay, so once you run this code, the raw output would be of this form. You will get bounding boxes and also some extra code here, you can see. And that is why we are going to use extract JSON to remove those pieces from the output and get this JSON object right here. Okay, and then we are pretty printing the JSON object, and we are returning the bounding boxes. Okay, so now we are ready. So this was a function that we are using, a method that we are using, and now we are ready to use it. All the pieces of code that we have written in this notebook, we are ready to use it. Let's look at the message first. Here we have done two things. In the previous notebook, we had not used the system prompt. Here we are going to use the system prompt, and let's see what the system prompt is. In the system prompt, we are saying you are an object detector. All right. So basically, it is focusing its energy on object detection. We are telling it what it is, and then we are saying the format of your output should be a valid JSON object of this form, right? So we are saying that this is the form of the output I need, where class, it's basically x1, x2, and these are the 2 points, the 2 corners of the bounding box. This is what it is going to output, where class is the name of the class that you are detecting. So this ensures that we do not have to say that return the JSON object again and again. It knows that the output should be in JSON format. Second, we have the user prompt with the role user. We are saying, this is the image. So we are passing it in the image, and then we are passing in the text, right? Which is basically outline the position of elephants, right? If you run this code, you will get this bounding box, right, with all the elephants. Let me run it so you can see that you got the position of the 2 elephants. So let me run this code one time, and you will see that the elephants would be displayed. Just takes a little bit of time. We'll get to this point very quickly. Okay, so now it's running and we got the elephants. All right, so that is really nice. Now we can also say outline the birds, right? There are 2 birds there. If you did not notice, you'll notice that there are 2 birds here, and I want them to detect those birds also, elephants and the birds. Okay, so we are going to run this cell, and let's see what the result is. All right. So it detected the elephant, bird. Excellent, right? Now let's look at, so this is basically an object detector, 0-shot object detection, because we did not train the model, right? And it's not just elephant and bird. You can pretty much do anything you want that is normally used in English vocabulary. Now, let's do some interesting things, right? Find the position of the left elephant, right? We don't want all elephants, only the left elephant. So let's see what happens. Ooh, that is the left elephant, right? This is very interesting, because if you had trained a normal object detector, using YOLO or something, you would have to write additional code to do this left and right idea, right? So this is very interesting. Now, obviously, we can also use some other characteristics. We can also say, find the position of the bigger elephant. Okay, so here, very interesting. We added these adjectives to the elephant, bigger or on the left, and it is able to figure out automatically which is the bigger elephant, and it's only outputting one result, right? Now let's give it some, these are very very interesting things that you can do. We can do all kinds of adjectives to this object detector. Now we can also do smaller, obviously, small elephant, right? All right, so small elephant also works. Now let's do something that will blow your mind, right? Now, every VLM, right, it has a very deep understanding of language, right? And it is not trained on very specific things like large, small, etc. It basically understands language in a very profound way, right? So let me give it something which is very human, right? It is a very human way of saying, outline the position of a mama elephant, right? I'm not saying big, small, or things like that, which have very, obvious connotation, right? You know what is big. You can mathematically you can say what is big and what is small. But if you want to find mama elephant, right, it needs deep understanding of the language and the context. So it needs to know that when there is a small elephant and a big elephant, most likely the big elephant is the mama elephant, right? And let's do that and see what happens. Yes, it actually got the bigger elephant, right? That it thinks is the mama elephant. So this is a very powerful model, right? And I hope that you are able to use this notebook, do various other things with it, try to expand and experiment with it, and figure out what are the wonderful things you can do with a vision language model, right? Very powerful tool. It basically combines our visual understanding with the world knowledge that is embedded in large language models, right? So with that thought, happy learning. Thank you so much.